Hi, in this video I'm going to show you that the angle made by the two ends of a diameter with any other point on the circumference of a circle is always 90 degrees. The chord AD is the diameter because it passes through the center of the circle, point C. The angle subtended by the diameter is the angle ABD. We can place the point B anywhere on the circle except points A or D if we want to form a triangle. It is of interest to note that the angle ABD is always 90 degrees. If we say this another way, the chords AB and BD are always perpendicular to each other, regardless of where we place the point B on the circumference. This is a subject of Euclid's Elements, Book 3, Proposition 31. How can we know this? Let's start with a circle and mark the center with a black dot, labeling it point C. Let's draw a line across the circle such that it goes through the point C in the middle. This line will intersect the circle at the 2 points labeled A and D. The chord AD is the diameter of the circle. The distance from the center of the circle to any point on the circumference is the radius, which is labeled R. Now pick a new point, any point along the edge of the circle. I've chosen a point and labeled it B. Recall that the angle of a straight line is half of a circle, which is 180 degrees, or pi for the savvy. In addition, recall that the interior angles of a triangle add up to 180 degrees. This straight angle has been shown at the point C on the diameter as an example. Connect points A to B with a straight line. This is the chord AB. Connect the points B to point D with a straight line. This is chord BD. Connect the center point with the point B. The length of line CB is just the radius. The length of AC and CD are likewise the radius. All of these have been labeled with an R to make it clear that they are the same length. We don't know the lengths of AB or BD, and we don't care. Notice that we now have two isosceles triangles. If you want to learn more about isosceles triangles, please watch the video, Isosceles Triangles. The first isosceles triangle is shaded pink, and the second isosceles triangle is shaded green. They share chord BC. Because of the properties of isosceles triangles, the angle CAB in the pink triangle is equal to angle CBA. These two angles have been labeled with alpha. Similarly, the angle CBD in the green triangle is equal to CDB. These two angles have been labeled with a beta. Now let's consider the triangle ABD shaded in blue, which is simply the pink and green triangles added together on the previous slide. Recall that all the interior angles of a triangle add up to 180 degrees. As a result, in this triangle, we can easily see that alpha plus beta equals 180 degrees. Therefore, 2 times alpha plus 2 times beta equals 180 degrees. This means we can divide by 2 to find that angles alpha plus beta equal 90 degrees. This is a right angle. This is the angle subtended by the diameter on a circle. Thus the demonstration is complete. Now you know why. In summary, the angle resulting from connecting any point on a circumference of a circle to the two opposite ends of a diameter is always a right angle. Any triangle thus formed is always a right triangle. Please visit our website and contact us if you would like personal tutoring in math.